In this virtual titration lab experiment, you will be preparing a dilute solution of sodium hydroxide and then standardize this solution to 3 significant figures using potassium hydrogen phthalate, abbreviated KHP. To first prepare the solution, you will use 1 molar sodium hydroxide. You will also need distilled water and a volumetric flask. When preparing 250 milliliters of a dilute sodium hydroxide solution, if I was to choose 0.5 molar, using the stock solution of 1 molar and the molarity calculation of moles over liters, I would need 125 milliliters of hydroxide solution and approximately 125 milliliters of distilled water. I can duplicate these individual solutions so that way I have enough. You can add the sodium hydroxide to the flask and continuing on adding an additional 25 milliliters and then adding the distilled water. After you add the first 100 milliliters of distilled water, you should add the remaining amount slowly in order for the meniscus to reach the 250 milliliter mark as indicated on the flask. To do this, you can go through the realistic setting and slowly add 200 water to the 250 milliliter mark. Now you have prepared your dilute sodium hydroxide solution, which you will then standardize with the potassium hydrogen phthalate. With your sodium hydroxide solution prepared, you can now standardize this using a pre-standardized solution of potassium hydrogen phthalate, or KHP, which is already known to 3 significant figures. You will need the 0.500 molar KHP solution, phenolphthalein, and a burette. First, you will need to add phenolphthalein indicator to your KHP solution. You can add approximately 1 milliliter. Then you will be adding your standardized sodium hydroxide solution to the burette. The burette is meant to deliver 50 milliliters and is indicated as a 50 milliliter burette. But if I add 50 milliliters, it does not fill it completely. The markings on a burette are meant to indicate how much leaves the burette and goes into the flask, not how much is currently in the burette. After adding 50 milliliters, I am still only at the 2 milliliter mark, and I can add an additional 2 milliliters. The solution does not need to be at the 0 mark to start, but you must record the accuracy up to 2 decimal places. You can then start the titration by adding the hydroxide from the burette to your KHP solution. You can do this through the realistic setting where you hold to pour small amounts of solution at a time. Knowing the approximate concentration of your sodium hydroxide solution, you can add larger amounts at the beginning and then smaller amounts as you get near to the expected endpoint. In my setup, my sodium hydroxide solution was approximately 0.5 molar, the same as the KHP solution. So I would need approximately the same volume. In this case would be 25 milliliters. As you add sodium hydroxide, you should start to add it slower and slower as you get closer to the endpoint. You will notice it was not exactly 25 milliliters, which is very consistent with in-lab titrations. You can then slowly add small amounts of sodium hydroxide to your KHP solution until the indicator changes color. As you can see, it is beginning to change color, and therefore the endpoint is reached. You can now record what the total volume of hydroxide was needed to reach the endpoint. At that point, you can refill your burette and obtain another solution of sodium hydroxide to repeat trial 2. You will prepare 3 trials and calculate the average concentration of your sodium hydroxide solution.